Hi, everybody. Welcome back to Dave's Math Channel. I'm your host, David Tear, and this is my continuing feature on the Math Lovers book. Might as well give another plug for it. This is going to be a very short video today, by the way. But I might as well just talk about my series a little bit. It's called the Math Lovers book. There's 3 volumes. As you can see, they're all shown on the slide, and I'm still going through volume one. I'm a little over halfway down. There's 10 chapters in this volume, and it's more recreational math, I think, for the most part. Right now, I'm talking about group theory, which is a pretty complicated area of math, but I think it's also a fun area, and it has a lot of very important applications, and it's something really most people don't learn in school that much, although I think they could. Anyway, that's part of volume one. Volume two is more academic. That has more like first or second year college level. I go over kind of standard academic topics like functions and differential integral calculus and probability and statistics. And at the very end of volume two, there I have 80 short biographies of famous mathematicians throughout history listed chronologically. I'm featuring those on this channel as well. I've already featured, I think, 17 out of 80. So that's also a continuing feature on this channel, concurrent with this, my academic lessons. And then finally, volume three is problems and solutions pertaining to the first 2 volumes. So that's pretty much the Math Lovers book in a nutshell. And if you want to purchase it, you can either purchase it on Kindle or on paperback on Amazon. You can just search for my name or for the Math Lovers book. I think it's a good bargain. I can't remember how much I'm charging right now, but I would really appreciate it if you bought a copy. It's not that expensive. At the very most, I think they're like $40 for the paperback and 20 for Kindle. They're probably less than that. I don't remember last time I repriced it. I'm not a salesman, unfortunately. Uh, Maybe I don't have that kind of mentality. I don't know. I like math. I like numbers, but I'm not so crazy about just trying to make a lot of money or I mean, I did make a lot of money investing a few years ago. I'm not going to get into that. I'm a little bit high. I had some pot about an hour ago, so I'm a little kind of recovering from that. Maybe that's why I'm rambling a lot right now. But anyway, maybe we should just get into the lesson for today, which is on alternating groups. And anyway, let's just begin. So, what is an alternating group? That's really all I want to talk about in this video. I think last video I mentioned even and odd permutations. We were talking about permutations. I've been talking about permutation groups for the last 5 or 6 lessons, and I think I defined permutations and the group of all permutations of a given finite group set is called the symmetry group of that set. But if you only include the even permutations, which I did, I think, tell you that makes a group last time, that's a subgroup of all all the permutations, subgroup of Sn. That's known as the alternating group, and the symbol is given for as A sub n. So S sub n is the full symmetric group. That's the set of all permutations of a given finite set, which does form a group if you compose them. And the alternating group AN is the collection of all even permutations of that set. In other words, permutations that are formed from the product of an even number of transpositions, which is exactly half of all of them, unless n is equal to 1, in which there's only one permutation. That's a trivial group. We don't really care about that one. S1 is equal to A1. But as long as n is at least 2, the size of AN is half the size of Sn, which is n factorial over 2, since last time I think I mentioned that the order of S sub n is n factorial, which is a very fast growing function of n. A sub n is half of that. So that's also very fast growing. It's just half as big as S sub n, but that can get really, really big too if n gets large. And here's a table. This is a table of the order of S sub n and the order of A sub n for n going from 1 to 10. The numbers in the middle column are just the factorials and factorial, and then the numbers in the rightmost column are n factorial over 2, except for the case where n equals 1, or it's just 1 factorial or 1. So anyway, those are the orders of the alternating groups. We're going to see a lot of examples of symmetric groups and alternating groups pretty soon. I think this will get a little more fun. I mean, permutations are kind of an abstract topic and kind of a lot to take in when you first learn them. But I'm going to return to geometric symmetries. Remember, we were talking about geometric symmetries of 2D figures. The next thing I'm going to talk about is symmetries of 3D figures, and I think these are even more fun than 2D figures. So anyway, that's just a little preview of what's coming up. But that completes my video for today. So thank you for watching. Long live math, and I'll see you guys next time. Bye.